Hello students, welcome to mathematics class. Students, this is part 1 of the new chapter called Factorization. In this part 1, we will be seeing introduction of this factorization. Later, we will go for learning factors of natural number and factors of algebraic expressions. Students, as part of the important factors of natural numbers, you all aware of any natural number. Let's say, let us take a natural number, say 30, and write it as a product of other natural numbers to understand what are the factors of 30. Now, coming to the 30 can be written as 2 into 15. Later, it even can be written as 3 into 10, and even we can write 30 as 5 into 6. Children, you must be getting doubt now that can't we write it as 1 into 30? Yes, certainly it can be written as 1 into 30, but try to understand here. In 2 into 15, or when we write it as 3 into 10, or when it is expressed as 5 into 6, we can say those multiples are factors of this product 30. Whereas when we write 30 as 1 into 30, is it special to say that 1 is a factor of 30? Is there any special when we write any number as 1 into the number itself? No. Here, unless until there is a special requirement, we need not write a number as 1 into that number, because every number can be expressed as product of it by 1. So 1 is a common factor to every number. So that's why we avoid that way of writing. Apart from that, we have got now the factors of 30 being 1, 2, 3, 5, 6, 10 and 15 as well as 30. So these are the factors of 30. You have learnt in your previous classes, that is class 6th and 7th, way of finding factors for the given natural numbers and factors of natural numbers. Now moving further, amongst these factors 2, 3 and 5 are prime factors. Do you know why? Because 30 can be expressed as the product of 2, 3 and 5. Since we can write 30 as I'm writing 30 as 2 into 3 into 5. We call these 2, 3 and 5 being prime factors for 30. A number written as a product of prime factors is said to be in the prime factorization. So therefore, we can say writing 30 as 2 into 3 into 5, that prime factorization of it. Now, for example, 30, when we write it as 2 into 3 into 5, that is in the prime factorization of it, each that prime number is prime factor and 30 is in prime factor form. We call 30 is in prime factor form. Now, prime factors we shall find out for the rest of the, or for some other numbers such as 70. Let's say when I take 70, what would be the prime factorization of it? The prime factorization of 70 is 2 into 5 into 7. Similarly, what is the prime factorization of let's say 90? 90 can be written as 2 into 3 into 3 into 5 Or even we can write this 90 as 2 into 3 square into 5, where we say 90 is in prime factorization or is in prime factors form, and prime factorization of 90 is 2 into 3 into 3 into 5. Now let us move on to the another important topic called factors of algebraic expressions. You know what are algebraic expressions? In algebraic expressions you normally find terms, and these terms, when you consider, each of them are formed as product of some factors. They may be numbers and variables. Now let us take some example for it. In an algebraic expression 5xy plus 3x, there are two terms. Let's see the term 5xy, how does it can be being in factor form. In that term 5xy, you could see the factors 5, x and 5. That is 5xy, since it can be written as 5 into x into y. Now observe that the factors 5x and y of 5xy cannot be further expressed as product of factors. It cannot be further expressed as a product of any other factors. So that's why we say this 5, x and y as a prime factors of 5xy. But instead of the word prime, we will use some other alternative term, that is irreducible. In the place of prime, I'll use the word irreducible. So this 5xy is in the factorization or as a product of irreducible factors. It is in the form of product of irreducible factors. Which are those irreducible factors here? 5 is one, x is another, and third is y. So 5xy is expressed as the product of those irreducible factors. So we say 5xy is in irreducible form. Rather, in prime factorization of natural numbers, we said prime factor form. In algebraic expressions, the term 5xy is in the irreducible form. Now, can I say 5 and xy, that is the product of xy, are they two of them irreducible form? No. Why? Because xy can be further written as the product of x and y. So I cannot say xy is in irreducible form. Xy is in the form of reducible. Since it can be written as product of x and y. You have to observe when some term is said to be in irreducible form, whether the coefficient, that is numerical factor, or literal factors, are they further can be reducible or not. That is a prime important observation which you need. Now, taking it further, we have some other example. 3 into x into x plus 2. Observe here, x plus 2 is within braces, which is nothing but, here I have 3 multiplied by x, and that product is multiplied by the sum of x and 2. So here can I say these factors 3, x and x plus 2 are irreducible? Yes, we can say them, because they cannot further be simplified or can be written as the product of some other factors. So they are irreducible factors. So now this expression is said to be in irreducible form, since I have written 3x into x plus 2 as 3 into x plus 2. So the factors 3x and x plus 2 are irreducible factors only. Now let us take another example. The expression 10x into x plus 2 into y plus 3. Now here you could find 4 factors, that is 10, x, x plus 2 and y plus 3. Can I say they are in irreducible form? No. Though you could find x, x plus 2 and y plus 3 being in irreducible form, but 10 can be further reduced as the product of 2 and 5. So thus the irreducible form of this expression is 2 into 5 into x plus 2 into y plus 3. Observe, here you have x plus 2 within braces and y plus 3 within braces, which means the product of 2, 5 and x is multiplied by the sum of x plus 2, and further that product is multiplied by the sum of y and 3. So we use normally distributive property now, like that. Here coming to the what is the meaning of factorization? Children, whenever we express any given algebraic expression as the product of irreducible factors, then that algebraic expression is said to be in factorized form, and we say that that algebraic expression is factorized. So the factorization is just nothing but writing the given algebraic expression as the product of some simpler, which means irreducible factors. Once again I'll repeat. Here you could note down this definition. Factorization of algebraic expression is writing the given algebraic expression as the product of some simpler factors or some simpler irreducible factors. So far whatever I have discussed, that is 10x into x plus 2 into y plus 3, 3x of x plus 5, they are all examples for factorization. These factors may be numbers or they may be even algebraic variables or some other algebraic expressions too. Like in 3xy, you have got 3 being number, x and y being variables. Whereas in 5xy square, you have got 5xy being variables. Whereas in the example 2 into x into y plus 2, you have got 2 being number, x being variable and y plus 2 being another algebraic expression. So same case is with y into y plus 1 into x plus 2. These are all examples. They are already in factor form. So their factors cannot be just read off from them, as we already know them. On the other hand, consider expressions such 2x plus 4, 3x plus y, 3x plus 3y, x square plus 5x, x square plus 5x plus 6. Here these are algebraic expressions which are not in the factorized form, since they can be further reducible to the product of some simpler factors. Now I am going to explain you that how to factorize given algebraic expression. We need to develop a systematic method of doing this factorization, children. I am going to explain you that methods. What are the methods of factorization? We have three important techniques of factorizing. First method or a technique is factorization by taking out common factor. Second, factorization by regrouping terms. Third, factorization by using algebraic identities, what you have already learned. Coming to the first technique, method of common factors. Now we will begin with the same example what we have seen. Suppose if I are asked to factorize 2x plus 4, we shall write each term as the product of irreducible factors. That is 2x can be written as 2 into x, 4 can be written as 2 into 2. Now 2x plus 4, when it is written as 2x plus 2 into 2, there is 2 common. So we call that in these two terms 2 as a common factor. So I say common factor of 2x, term 2x I mean, and term 4 is that 2. I will take out that 2 as a common out. Now I will have this 2x plus 4 becoming 2 into x plus 2. So or we normally write 2 times of x plus 2 or twice of the sum of x plus 2. This is what you have learned in your class 6th while forming algebraic expressions. So the factorization of 2x plus 4 is 2 into x plus 2. So this is one example. Let us take some other example. If you are asked to do factorize xy, 5xy plus 10x, 5xy plus 10x. Now individual terms I am writing as irreducible form, and 10x, 5xy I have written 5 into x into y, 10x I have written as 2 into 5 into x. Here you could see 5 and x being the common factors. So I say common factors of this 5xy and 10x are 5x. Therefore I can write now 5xy plus 10x, which is in the irreducible form as 5 into x into y plus 2 into 5 into x. After taking 5x common out, 5x of y plus 2. Thus the factorization of given algebraic expression 5xy plus 10x is 5x into y plus 2. So this is how we do factorization. I'll take one more example for doing factorization using method 1. Factorize 12a square b plus 15ab square. Children, I'll not go for separately writing. Here itself I will write. So solution, you know 12a square b can be written as 2 into 3 a square b, that is 3 into a square b. 15 can be written as 3 into 5 into a into b square. Now you could see 3, 1a, 1b being common. So I say common factors of 12a square b and 15ab square is 3ab. So since I found that, I am taking 3ab common out. Now I am left over with 2 into 2 into 1a plus in the second term I am left with 5 and b. So the factorization of given algebraic expression 12a square b plus 15ab square is 3ab into 4a plus 5b. So children, with this I'll wind up this session, and in our next session we'll continue from the same techniques of factorization. So till then, take care of yourself. Jai Hind. Thank you.